Vector search misses exact words, and keyword search misses meaning. LanceDB gives you a local hybrid retriever for RAG in Python, then re-ranks results before generation. This is the pattern you'll be able to implement by the end, which indexes local texts and retrieves using combined keyword and vector signals. Then re-ranks. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. Search for facts in a local collection is messy. Exact identifiers like product codes need keyword matches. Fuzzy user language needs vector similarity. If you rely on only one approach, you miss either precision or recall. A hybrid retriever blends both signals so you surface exact matches and semantically relevant documents in the same pipeline. At a high level, the idea is simple. Index your texts with a small table. Build an exact token index over text and IDs for keyword lookup. Also, store lightweight embeddings for vector search. At query time, collect candidates from both, merge scores, and finally re-rank to pick the best passage to feed into your generator. We will build a tiny local demo that shows these steps end to end. It stays on a small dataset, so you can run it on your laptop. The code will seed a table, enable a keyword index, run a vector search, fuse candidates, and then apply a simple re-ranker that boosts exact ID matches before generation. This snippet connects to a local LanceDB database and seeds a small table for later retrieval. The function embed creates a simple normalized vector from token counts, so each document has a deterministic embedding. The variable db holds the database connection returned by LanceDB connect, and docs is a short list of dictionaries with ID, text, SKU, and vector fields. The call to create table writes the rows into a table named docs, replacing any previous version. Finally, count rows confirms successful insertion. The printed row count shows the table is ready for search experiments. Next, we build the keyword search index and try a text lookup. This example enables LanceDB full-text search over the text and SKU fields, then executes a keyword query. The function createFTS index builds an internal Tantivy-backed index, so exact tokens, like product IDs, are searchable without an external engine. The call to search with query type set to FTS runs the keyword lookup and returns the most relevant rows. Using limit keeps the result set small for demonstration, and toList materializes the matches as Python dictionaries. The top variable holds the highest scoring hit from the full text pass. The printed ID and SKU confirm that an exact identifier can be surfaced reliably via LanceDB FTS. Now we ask the same question using embedding similarity to see what semantic retrieval returns. This code performs a vector similarity search in LanceDB to find the nearest document by embedding. The variable QV holds an embedding for the query text built with the same embed function used for documents. The call to tbl.search with a vector initiates a dense search over the vector column, and limit picks the top candidate. The toList function returns the result rows as dictionaries, so fields can be accessed directly. The hit variable stores the best semantic match. The printed ID and text show which document vector similarity alone would choose, illustrating how dense search can find related content even without exact keywords. Next, we fuse keyword and vector results to build a hybrid candidate set. This snippet builds a simple hybrid retriever by fusing candidates from LanceDB, full text, and vector searches. The variables v and k capture top results from tbl.search using a vector and an FTS query, respectively. The dictionary S accumulates scores by giving higher weight to higher ranked items via an inverse rank scheme. Each occurrence across modalities contributes additive evidence, improving recall when either dense or keyword signals are present. Sorting the aggregate scores selects the final best candidate. Increasing the limit widens recall but adds latency. Decreasing it speeds up at the risk of missing viable matches. The printed hybrid score confirms combined evidence elevated the winner. Finally, we re-rank the fused candidates with a practical bias toward exact identifiers. This code finalizes a tiny baseline by re-ranking hybrid candidates with an exact match boost. The dictionaries SV and SK hold inverse rank scores from vector and FTS searches, and the function boost adds a strong bonus when a skew equals the query. The comprehension builds a weighted sum per candidate, prioritizing dense similarity 0.6, keyword relevance 0.3, and a decisive exact ID preference. Sorting the scored list selects the best overall item without introducing any external search service. Increasing the boost sharpens precision on identifiers. Lowering it gives more room to semantic matches. The printed ID and final score show the boosted reranker promoting the precise hit. In a real project, this tiny demo maps directly to product search or document retrieval. Seed a larger table, store embeddings for each passage, and run the same hybrid and re-rank steps to produce a short list for your LLM to synthesize into an answer. Recap. It is a local hybrid retriever that combines LanceDB full text and vector searches, and then re-ranks candidates. Use it when you need both exact identifier precision and semantic recall in the same system. Caveat: the simple inverse rank fusion and fixed boosts are a baseline, so tune them for your dataset. Next step, tune the reranker by adjusting the boost to trade off identifier precision versus semantic recall, and measure the impact on your downstream answers. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.